Hey everyone, welcome to Code Harmony. Today we are going to solve LeetCode Problem 38, count and say. This problem is important and based on the concept of string compression. Also asked in almost all the tier 1 companies, Google, Amazon, Microsoft, Apple, Adobe, PayPal and so many more. Also it is marked as medium, but it will be easy to understand. Let's have a look on the problem statement. Here they are saying that the count and say sequence is a sequence of digits defined by the recursive formula this. So this is a recursive definition of count and say sequence. They are saying that if the value is 1, input value is 1, then it is going to return 1. Consider it like a base case. Otherwise, count and say sequence of n is the run length encoding of count and say n minus 1. This is our function count and say, getting integer as an input, returning some string, and the same function we are calling in the subsequent code, count and say with lesser parameter. So ultimately the base case is going to handle this recursive condition, and every step whenever we are calling the base condition, the smaller function call, we are doing the run length encoding of this string from subsequent code. So this is just a definition of count and say formula, and they are saying that what is run length encoding. I will just explain it directly to you. After this, they are saying that a given is positive integer n, and we have to return the nth element of the count and say sequence. Nth element of count and say sequence. So this is our problem statement. If I just have a look on the example, if the input is n equal to 4, then the run length count and say sequence will be 1 2 1 1. And how this is formed? By the same recursive condition. Count and say, let's say a function. Here the function is count and say sequence. Count and say sequence. So count and say sequence of what? Count and say sequence of 4 is going to be equal to the run length encoding of count and say 3. And this is equal to the run length encoding of count of say 2. Run length encoding of f of 1. So f of 1 is the base case, count and say 1. This is the base case. So this base case is going to return 1. And what I have to do is, I have to do the run length encoding of 1. And what is the run length encoding of 1? Now just have a look on this encoding method. What is this run length encoding? Whatever string is given to us, we have to do some sort of encoding that count the same type of digits. Let's say in this case, if I start with 3, count the same type of digit. 3 is coming 2 times, 3 is coming 1 time, 2 time. So count is 2 and the current character is 3. And now in the encoded string, I will write it like this. 2 times we are encountering 3. And after this, when I encounter the new character, I'll just keep on capturing the count. 2, 2, 2. And 3 times we are encountering 2. After that, 1 time I am encountering 5 and 1 time I am getting 1. So this is the run length encoding of this function given in the same paragraph. Run length encoding of any string. Let's say this is the string. So it is going to be something like this. 3 is coming 2 times. 2 times we are getting 3, and 3 times we are getting 2. 1 time we are getting 5, 1 time we are getting 1. So replacing this 3 3 with 2 3 in this case. So this is my run length encoding, and if I just write it here, you will be able to get it. So first character is 1, character is 1, count is also 1. So 1 time I am getting 1. So this is the run length encoding of 1. And now we have to do the run length encoding of 11 1 1, and this is going to be equal to 2 times we are encountering 1. So this is 2 times we are encountering 1. And the run length encoding of 2 1 is character is 2, count is 1. So 1 time I am getting 2, and after that 1 time I am getting 1. 1 time I am getting 2 and 1 time I am getting 1. So this is the final result of this example. That's how I am getting 1 2 1 1 4 4. And what I did here is nothing, just whatever is given in the problem statement, that a recursive statement is given to me which is the implementation of count and say sequence. And in this count and say sequence, there is one utility function which is Run-Length Encoding, and the Run-Length Encoding I have to do by my own. So if I just try to write a recursive form, this is given to me. Count and say function, input is an integer, output is a string. So base case is if the integer value is 1, then directly return 1. Otherwise, just take the Run-Length Encoding of function of n-1, a smaller function. This is my problem and this is my smaller problem. And ultimately, if I just keep reducing the problem, I will be getting on the base case. So this Run-Length Encoding is something I have to implement by my own. Otherwise, this definition is already given in the problem statement. Okay, so this is the recursive form I have already written. Now just try to implement the RLE function, Run-Length Encoding function. See how we are going to do the Run-Length Encoding. What I did here, I firstly iterated over every single digit, and I maintain the count of the current occurrence, how many times it is coming, and if I am getting a new occurrence, then previously captured occurrence just add it in the answer. So I definitely be going to start from the left and going till the right. Let's say this pointer is I in this case, and if I'm first of all, whatever function we write, we have to do what is our initialization. Our state initialization is I equal to 0 and my current character is 3 and current character count is 1. So this is the state I am having right now. After this, I will just keep on going, or in other terms, what you can do is you can initialize with this and start your journey from the next pointer, right? First of all, let me also have a look on the constraints. In the constraints, n value is definitely be going to greater than equal to 1. N value is going to be greater than equal to 1. So we can't get a value less than 1 for the Run-Length Encoding. So least value we can get for the Run-Length Encoding is 1 as shown here. So it means at least one character I'm definitely going to have. So for that, what I can do is I will just initialize it from 1 instead of 0. So I is equal to 1. If I just mark the pointer to the correct position, I is 1. This is the initialized state, and previously, let's say I have already captured this current character. Character is 3 and count of this character is 1. My initialized state is ready. After that, I just have to iterate over every single character and see whether this character is equal to the previous one. If it is equal to the previous one, my character will remain same, my count will be incremented. Here my I is definitely going to start from index 1 for I equal to 1, I less than n, I plus plus. If my current character value at the current character is equal to ch. Ch means my current character that I'm taking count of. So if it is equal to current character, nothing to do, just increment the count plus plus. So currently character is 3, count is 1. Now at this position, count will be incremented. So this is the first case. And what is the second case? Second case is when the current character is not equal to the previous one. If it is not equal to the previous one, it means previous one is totally calculated, and just save it. And how we can, where we can save it? We can have a StringBuilder, or you can say string, or any mutable string, sorry. So I have taken mutable string, so because we are going to do a lot of operations. So you can take any string or character or list or vector, and here in the else case we are encountering ith pointer is not equal to the previous one. It means previous one is already captured. So when the state is something like this, I is coming to this pointer when I is equal to 2, it means the current character is 3 and count is so far captured is 2. So we have to save this state. So StringBuilder dot append. First of all I have to append count, and then I have to append character. Firstly append the count and then append the character, and after that I will reset my current character. Character is character at I and count is 1, because at least at this position the element is present. So this is the state when the current character is not matching with the previous one, and while doing the iteration my I is definitely be going to increase. So yeah, that's all we have to do. And there is one catch. Let's say the string is something like this, similar to this. Until 5 I have captured the stuff. When I'm coming to 5, when I'm coming to 1, my current character is not equal to the previous one. It means current character is updated and current count is updated, and after this my increment is done to this iteration pointer. So when I'm going to capture this one, it means after this for loop I also have to capture one character. So whatever is the final character and the count, I have to capture that as well. So if I just try to write it in a clean manner, my initialization is I is equal to 1, current character is current character at 0, and count is 1. Now I will be writing a for loop where I will be starting from 1 and I will be going less than n I plus plus. If the current character is equal to the previous one, then I just have to increment my count. Else case means capture. Append, first of all add count, then append character. Here I'm going to capture stuff, capture the details. After the capturing I need to update my character, update character to current character, and update the count to the 1. That's all I have to do. And let's dry run it over the same example. 332251, 332251, and in this case if this is my I equal to 0, I'm going to capture it in the initialized state. Initialized state is character is equal to 3 and count is equal to 1. So now I will be starting with 1. So this is my current state. I is 1, character is 3, count is 1. So at I equal to 1 I will be checking it with the previous one, whether the current character is 3, it is equal to the previous one which is also 3, then increment the count, incrementing count to 2. Then I will move I to the next pointer, because else part is not going to run. Now I is equal to 2. Current character is 2, which is not equal to the previous one. Definitely I will be going to the else part. In the else part what I am doing is currently capture the state. Capturing state means whatever is the string builder. String builder is going to be, I am going to append 2 and then appending character. So this is my current state of string. Then move to the next character. Next character is 2 again. See, after appending I have captured the current character as well and count as well. After capturing I updated the character to 2 and count to 1, and then I will move next. When I am moving next, this 2 at the index 3 is equal to the previous one, so definitely increment the count. Count is now incremented to 2, current character is also 2, and then move to the next iteration. Next iteration at index 4, character is 2, character is same as the previous one, increment count is 3. Now move to the next iteration, I equal to 5. At I equal to 5 the value is 5, which is not equal to the previous one, so I will just capture it. To capture it, add the count and the character, and then update the character and count. Character is now updated to 5 and count is now updated to 1. Now I will move to the next iteration, I equal to 6. Here the character is 1, which is not equal to the previous one. So capture the previous one from the else part. One time I am getting 5, and then update the character and count. Character is updated to 1 and the count is also updated to 1. Now my current I value is 7 and I have gone out of bound. I pointer has gone out of bound. I is less than n. So it is going to break the loop. If it is breaking the loop, I have to capture this character, the last occurrence. This is not captured in the string. So one time I'm getting 1 as well. So after this for loop, I have to do one more thing. StringBuilder dot append count and append character. So this is my implementation of running length encoding function, and this running length encoding function I'm going to call as a utility function in this string. So now my recursive solution is over, and running length encoding is just a utility function, and this recursion is already what is given in the problem statement. So now this is over, and here we have to analyze the time and space complexity of this approach. See, you might be seeing that okay, every time we are calling a subsequent call. So from 4 I'm initiating call for 3, initiating call for 2, initiating call for 1, and every time we are calling this running length encoding algorithm, and this running length encoding algorithm is going to take a linear time. So you might see that it is n cross n time, but this is not n cross n time. If we just try to analyze the count and say function, we are doing the time and space complexity analysis now. If we have a look on the count and say function for n value, if the value of n is 1, the string is 1 and the length is 1. If the value is 2, string is 1 1, length is 2. Value is 3, the string length is 2, and the n value is 4, string value is 4. So far it is looking like linear one. If value of n is equal to 5, it is 6. For 6 it is 6. For 7 it is 8. And for 8 it is 10. Here we are having an idea that it is a bit more than just linear. A bit more than just linear. So if we just keep on going like this, at f equal to 15, when the value of n is equal to 15, I might get a length of around 54, which is definitely more than the linear one. For n equal to 20, I will be getting a length of 116. So the growth of the string is not linear. If the growth of string is not linear, we can't say that okay, every time we are taking around n time. So the string growth is way faster than order of n, and so the time complexity is also way more than n squared. This is because the string length is increasing with a faster rate than the value of n. And what is the increasing factor? This increasing factor we need to figure out. If we just try to analyze, you will see that okay, it is increasing around 1.3, 1.4, 1.5 times than the value of n. Okay, and if we try to analyze it further, after every 3 steps, from 1 to 2, 2 to 3, 3 to 4, after every 3 steps, the increment is around 4. So after 3 steps, 1, 2, 3, increment is around 4 times. So this is the analysis which is important. So increasing with a faster rate, around this rate, anything can be possible. And the main observation here is that after every 3 steps, my length is about to increase at a max of 4 times, 4 by 4. So after each 3 steps, my length is increasing by 4. So after ith step, my length will be increasing by 4 into 4 raised to the power I divided by 3. Because after every 3 step, my length is 4. So after I step, my length will be 4 raised to power I by 3. Just a mathematical equation. So this is the increase in the length. And if we try to have a look on the time here, every step my length is around 4 raised to power I by 3. Here I signifies the value of n I'm getting in the function count and say. So at every step I'm getting 4 is power 1 by 3, 4 is power 2 by 3. These are at a different stages of count and say function. So when value of n is equal to 3, I'm getting my string length around 4 is power 3 by 3, because whatever is the string length, that encoding function I have to run that time. So 4 is power 4 by 3, 4 is power n by 3. So if we just simplify this equation, it will come around order of 4 is power n by 3. So that's why it is not n into 4 is power I by 3. It is 4 is power n by 3. Right? So this is going to be the times I am having the running length encoding equation or comparisons. So the time will also be the same. Time complexity for this approach is going to be 4 is power n by 3, and this is also the space. Why? Because we are maintaining space to capture the string, and that is the same as the number of operations we are doing. So this is my time and space complexity of this approach, and I hope you have understood this approach. And this is more important, that how we are analyzing the time and space complexity, because the rate of increasing the string is not order of 1. It is more than that. It can be more 1.3 or something like that. But we are getting an idea that after every 3 steps, we are getting an increment of around 4, size 4 in our string. Here one more part is given, that could you solve it iteratively? See, we are doing the recursive function, whatever is given in the problem statement, that for the count and say function. And apart from that, this RLE function is definitely a iterative function. Here we are just doing the iteration and counting the encoding. So this function I can convert in the iteration form, and this approach in this solution will be iterative solution. So here how I can do it. Let's say count and say function f. I'm getting an integer n, and this string I have to return. Earlier we were using the base case, when n equal to 1, return 1, otherwise count and say of n minus 1. So when it was 4, I did for 3, I did for 2, I did for 1, and for 1 it is always 1, and we are going in the back direction. From 1 we are finishing up 2, finishing up 3, and then whatever is the value of the 3, the run length encoding of 3 is going to be my answer. It means if I am getting value n, then my answer will be run length encoding of n minus 1. Till n minus 1 I have to go, and starting from 1 I have to do the run length encoding of 1 as well. Here let's say I'm doing iteratively, starting from the smaller one first. Firstly, I was having a string of 1. Then I will keep on doing the run length encoding of it. So for I is equal to 1, I less than n, I plus plus. In this case, I have to do the run length encoding of 1. So string is run length encoding of 1, and it is going to give me 2, and for I equal to, last value of I is n minus 1. So for n minus 1 I am getting a string for n. So RLE of s, this is something we can do. And here if I just try to expand it, string is 1. If I do the run length encoding, it is becoming 2, and run length encoding of 2, it is becoming an answer for n equal to 3. And if I still do the run length encoding, it is becoming answer for 4. So for 4, for n, I have to go from 1 to n minus 1. So this is something we can do in the form of loop. And that's all. Now let's try the code, and the time and space complexity will be same for the iterative function as well. And yeah, that's all in the problem statement. Let's have a look on the code. Let's actually write the iterative function as it is given in the part of follow-up. So here For value of n, I will be going from 1 to n minus 1, and my initial string is 1, and I will be writing a loop for I equal to 1, I less than and I plus plus, and my current string is equal to RLE of s, and in the end I can return this string. So this is my function. This is my recursive function in the form of iteration. And what is the last value of I? That is n minus 1. So RLE of n minus 1 is string of n. So this is my last condition. Count and say of n is equal to RLE of count of n minus 1. Now I just have to implement this RLE function private, and this function is going to return string RLE, and it is going to take a string. I have to do the initialization. Before that, let's capture the first character of the string, s dot character at 0. This will definitely be having some length because the least value of s is 1. And what is the count here? Count is 1. So this is the initialized state, and I will be starting my iteration from I equal to 1. And what else? I also need to take a string builder. String builder sp is equal to new string builder, and while I is less than n. Now what is this n? N is equal to s dot length. Now I have my current character at I and the previous character in the form of ch. So if s dot character at I is equal to ch, I don't have to do anything than incrementing the counter. What is the else part? Else part is capture the current state. Capture sb dot append. First of all, enter the count and append character. These many times this character is coming, and then reset the state. How do I reset the state? Count is equal to 1, character equal to s dot character at I. Now the state is reset, and in the end I have to capture the last value updated or stored in this state, character and count. So sb dot append count dot append character. Now my function is done, and we can just directly return sb dot toString. I also need to increment the pointer before the next iteration. Now let's run our sample test cases. Sample test cases are passed. I'm submitting the problem. The problem is submitted successfully. In case you get any doubt, just comment down below or discuss in the Discord community. And thanks for watching, guys. Bye bye.